covalent bonds in molecules of compounds. All right, covalent bond in molecule of compounds. Like this is a covalent compound, right? Water. Everybody agrees to this. G. Do you agree that this is a covalently bonded compound? Yes or no? Hmm? Yes, Hadia, what do you think? Is this is a covalent compound, right? Why? All of these are covalent compounds, right? How are they covalent compounds? Can anybody tell? Yes, response, please. Everybody is able to hear me? Actually, it is better if I hear you guys because I want to know if everybody is connected and nobody is having an internet issue or anything. All right. Hmm? Hadia, is there any of the molecule or compound here that is not a covalent compound? What is how do you think if they are all covalent compound? How can you say that they are covalent compounds? How were you able to deduce that all of them are covalent compounds? No idea? जी इनली ये कैसे how are they all covalent compounds? Yes, Alishba, would you like to answer? Hello.
जी सर।
ये कैसे है कोवेलेंट कंपाउंड भाई? आधी से ज्यादा क्लास का टाइम इस चीज में गुजर गया यार. This is a simple question that you should be able to answer. By all of them are non-metals. If you look at water, they are the both of the compound, though both of the elements that are present in them are non-metals, right? In carbon and oxygen, both of them are non-metals. In carbon and hydrogen, non-metals. In nitrogen and hydrogen, non-metals. The bonding that is taking between these molecules is what? Covalent bonding, because this is a bonding between non-metal and non-metal elements. Why do we call them covalent compounds? All of them, why are they called covalent? Because they have bonding between non-metal and non-metal. That is why they are covalent compounds, right? We need to understand what is a covalent, what is a molecular compound. We have studied about We have already studied about molecular element. Can anybody give an example to me of a molecular element? Example of molecular element. Hydrogen, oxygen, nitrogen, right? Is this clear? All right. Molecular compound. When we talk about molecular compound, the molecules made from two or more different type of atoms. Molecules made from two or more different type of atoms. Different type. Different type means what? Different elements, okay? Atoms linked together by covalent bonding. These are the molecular compound. An example is what? What we have already studied. Examples are water, because there are many atoms that are linked together. Why? With covalent compound and are of different type, right? We have oxygen, which is linked with hydrogen and another hydrogen. We have carbon dioxide, which is linked with oxygen, another oxygen. You get it? We have NH3, or we can say we have methane, CH4. Carbon is linked with hydrogen, hydrogen, and hydrogen. Do you understand, everyone? So these are the examples. We're going to be analyzing each of them because they are going to be coming in an exam. We need to know how their structure is formed. So let's start with water. What we are studying are simple covalent compounds. Okay, they are simple covalent compounds. Do you understand? So first example that we have is water. Water is H2O, which means two atoms of hydrogen and one atom of oxygen. I've always mentioned multiple times, whenever you want to make an ionic dot and cross or you want to make a covalent dot and cross, if there are more than one atom attached to single atom, that atom should be drawn in the middle. The hydrogen and then hydrogen. Do you understand this point, everyone? Why did we draw oxygen in the right in the middle? Is because it is attached to two hydrogens, and whenever an atom is attached to two other atoms, that atom should be drawn in the middle, right? Do you understand? This oxygen is attached to two hydrogen. It needs to be, so this needs to be drawn in the middle. If you look, do you understand this point? So let's see how their configuration is going to be about. So oxygen is 2 and 6, hydrogen is 1, and this is 1. So the good news is that oxygen needs to share two electrons. How do we know? By looking at its electrons in the valence shell. We know anything in the group 6 has a valency of 2 negative. And how do we know? Because it needs two electrons to become octet. It needs two electrons to become an octet, right? So it is going to be sharing those electrons with any other element that is available. It needs to share two electrons to achieve this. Is this making sense? So it needs two atoms of which are sharing one electron to achieve that. Is this clear? If you look at oxygen and you draw the dot and cross, you will observe it needs two. It needs two because it has two lone electrons. So it needs two electrons to be shared with its two lone electrons, right? So on the other hand, if you look at hydrogen, hydrogen only has one and it needs to achieve octet. Another hydrogen only has one, it needs to achieve duplet, sorry, duplet. This needs to achieve duplet, this needs to achieve duplet, and this needs to achieve octet. So they are all going to be sharing electrons. So how are we going to draw this? This is the oxygen. This is one electron. This is another electron, and these are the two electrons that are there, right? For hydrogen, we can say that it only has one electron. For this hydrogen, we can say it only has one electron. So this is going to be shared between, you understand? So once they share, this is going to be how it is going to look like. Do you get this point? I want you to see this very carefully. Do you agree with me? This is hydrogen, and this is oxygen in the middle. This is how the sharing of electron has taken place. So how many pairs are they sharing? Alishba, how many pairs are they sharing? How many pair is oxygen sharing with one of the atoms? One atom only. Gee, I'm not able to hear you. So can you speak louder?
Two.
Sorry.
Two.
How many electrons are they sharing? Two electrons. And how many pairs are they sharing?
Yes.
How many pairs is oxygen sharing with one of the atom? How many pairs? Hmm? How many pairs? You don't know? One pair, right? Oxygen is sharing with hydrogen one pair, right? Each pair represents one dash. Is this right? So we can draw it like this. Hmm? The other hydrogen is also sharing a pair. This could be drawn like this. These are the paired electrons that oxygen had. Is this clear, everyone? Hmm? Any questions? So this is the dot. Sorry.
No question, sir.
Adia, do you understand?
Yes.
G.
So each pair is representing one dash, one bond. So oxygen has actually made two bonds, one with one hydrogen and one with another hydrogen. Do you understand? Is there any double bonds in there? No, all of them are single covalent bonds. Is this clear? This is called the structural formula.
G.
It's called the structural formula. H2O is called molecular formula. Okay, and this is called dot and cross. Dot and cross diagram. This could have also been drawn in this manner. You can also draw this like this. Okay. Represents the sharing of electron. This is clear, everyone? Everybody has written all of this?
Yes.
Let's take an example of carbon dioxide now. Rather, first let's go into the example of methane. When you look at methane, the molecular formula is CH4. So obviously, I've told you multiple times, whenever you are doing it, if you see that the carbon which has the least number is going to make up for the center, right? Center. So carbon is going to become the center, and we know where there are 4 hydrogens, so each hydrogen is going to be around it, right? This is the idea that we have when we look at this. We have placed carbon center because it is only one and the others are surrounding it. So the one which is the numbers which are lesser are going to be most probably in the middle, and the rest are going to be at the periphery around, right? When we talk about methane, contains 2 elements, right? Carbon and hydrogen. All right. So what is going to happen? Let's write carbon and let's write hydrogen. How many molecules are there in the carbon? Sorry, how many electrons are there in carbon? Can anybody tell? Hmm? No one? It's actually 6. It's going to be 2 and 4. How many does hydrogen has? 1. How many electrons does it need to share? Can anybody tell quickly? Adya, quickly. How many electrons does carbon need to form an octet configuration? Hmm? Eileen, can you tell how many electrons does this carbon need to achieve an octet configuration? Adya, can you tell? Hello.
G.
How many electrons this carbon needs to become an octet configuration?
4.
4 electrons, right? It needs 4 electrons. So each of these hydrogen can give 1 electron. So how many? If there are 4, then it can give 4 electrons to. It can share 4 electrons with the carbon. Let's look at it. So you need to draw the carbon in the middle, and you know it is surrounded by hydrogen, so they are going to be like this, right? 4 all attached to carbon. You understand? CH4 does not mean that any of this hydrogen is attached to carbon. It all means that all the hydrogens there are attached to the they are not attached with each other. All of those hydrogens are attached with carbon. Each of them is sharing an electron with hydrogen. We'll see. All right. So how many electrons are there in the carbon in the valence shell? Quickly, quickly. Alishba, how many?
Yes, sir.
How many electrons are there in the last shell of carbon?
4.
Sorry, I cannot hear you. Hello.
4, sir.
4? Yes, 4. 1, 2,
4.
3, and 4. Very good. 1, 2, 3, and 4. So each of this carbon and hydrogen has only one. Only one. So you need 4 of them to share their electron for each of them. There are 4. These are the 4. Now what students do is they draw like this. Now they are stuck. They cannot find the lone. They cannot see if there is any unpaired electron over there. You realize this? And this becomes difficult for them to solve the question. So always draw it like this. 4 electrons, 1, 2, 3, and 4. Right? So there are 4 electrons and 4. And then the hydrogen is going to bring its electron to share the electron here. This is the dot and cross that you're going to get. Or you can also make this dot and cross as such, which is generally not really necessary if you're already making the one like the above one. Do you understand? Each hydrogen is getting sharing one electron and also being shared with one electron. So it has this duplet configuration that it had to achieve as the first shell. And the carbon can also achieve its octet configuration by sharing these electrons 1, 2, 3, 4, 5, 6, 7, 8. Do you understand this point?
Yes, sir.
All right. Hadia, we were saying that this is the configuration that you can generally acquire and make for the dot and cross for carbon and hydrogen. Do you understand this point?
G.
Let's move ahead. Should we look at the another molecular compound, that is carbon dioxide? Can anybody tell, in order to make its configuration and dot and cross, what's the first thing that we need to do? D को बता सकता है? What is the first thing that we need to do? Obviously, write the electronic configuration.
Electronic configuration.
Very good.
Electron.
So carbon and hydrogen. Carbon has what? 2 and 4, and oxygen. Oxygen has what?
2 and 8.
2 and 6.
6.
Right. 2 and 6. All right. So let's look at them. And the formula tells us that there are 2, because each of them is going to be sharing 2 electrons, right? This needs total of 4 electrons, because it has 4 unpaired electrons that need to be bonded, that need to make a pair. That pair is going to be coming from oxygen. Each of the oxygen can give 2 electrons. It can give 2 electrons, right? So they need to be 2, and this could be 1. So if you look at carbon, has 4 of these electrons in its outermost shell, right? So if you bring 1 oxygen, We know that whenever you're going to be, whenever you have the atom or element that has the highest number is going to come in the middle. Okay. Now let's look at it. If you look at oxygen, oxygen has one, right? This is what we have. So each carbon can, one oxygen atom, it has generally two electrons, and it can share both of its electrons with the carbon atom here. Because, do you understand this point or no?
G.
Alishba, do you get it?
Yes, sir.
So these are full already. So carbon has already made a double bond with oxygen. Right? Still it has two electrons left. So it's going to bring in another oxygen atom. These two can now participate in bonding, making a double bond. Do you understand? So the formula for carbon becomes, so the structural formula for carbon becomes what? Carbon, double bond oxygen, carbon, double bond oxygen. Is this clear? Any queries? Everybody has written this down? Yes.